Let's study the topic second equation of motion. This formula is called second equation of motion. S equals to ut plus half at square, where S is what? This is displacement. U is initial velocity. T is time. Acceleration is acceleration, that is constant acceleration. And here T is time. Acceleration must be constant. This is a condition. This condition must be fulfilled, that acceleration must be constant. Then this formula can be applied. Okay. This is the second equation of motion. S equals to ut plus half at square. Let's see the derivation. There are two methods of derivation of second equation of motion. First method is graphically. Second method we know by calculus. Okay. For graphical, let's plot the graph. This is velocity. This where it is time. This is point P for initial velocity. This is, let it be final velocity point. This is initial velocity. This is final velocity. Okay. Let it be point T for time. Join this. Let it be point Q. Let it be point R. This one will be P minus U, as we already seen this diagram in first equation of motion derivation. The same diagram is here. Now let's see. This is, now we know that area under velocity time graph gives what? Displacement. Now what is this S? S is displacement. We have to find what? Displacement. Then what we will find? Area under velocity time graph. Okay, this is the area under velocity time graph. A body is going from initial velocity to final velocity in the time t. The graph enclosed is this, and so we will find the area of which figure? OTQP. This area OTQP, area of this shaded part will give the displacement. Okay, so at first we will write, since area under velocity time graph gives what? Gives displacement, and therefore displacement S is what? S is equal to area of what? Area of triangle PQR plus PRTU. This is, let's divide it into two parts. One is a triangle and another is a this rectangle. Okay, area of triangle PQR plus area of rectangle PRTU. You can write anything, you can write PRTU, OPRT or TORP, anything you can write. Okay, so area of triangle, this one will be what? This area will be equal to half into, as per the formula, what it happens? Half base into height. This is a right angle triangle. Okay, so half into base into height, that is half into base is PR into height is QR plus area of rectangle OPRT is what? This PRTO is what? So OP into this one PR. Length into breadth, OP into PR, and that is equal to half into QR is what? QR, this QR is V minus U. This QR is V minus U. How it is? QR equals to V minus U. This QR is V minus U. How it is? QR, it is, this length is equal to this length. Okay, and this length is what? This complete minus this, that is V minus U. So this is V minus U. And PR, this PR is what? This is T. This is simply T. Okay, plus OP is what? OP. This is U into PR is what? PR is again T. Half, upon solving it will get what? Half, let's elongate, half VT minus half UT plus UT. This will be equal to, then S will be equals to, this is, we can elongate it. And this, I think this is meaningless part. Why this is meaningless? We can learn here why this is meaningless. Because V minus U, we have already get UT, we have already get here UT, and then we have to get what? Half at square. So half we have already get T, 1T I have already get, then V minus U we have to get as AT. So from first equation of motion, what is that? V equals to U plus AT. We know that from first equation of motion, then it is V minus U can be written as AT from first equation of motion. So putting this V minus U by V minus U equals to AT here, this will become AT into T plus UT. Okay, so there is no need of this expansion and making it more complex. This is simply half AT square plus UT. So we can write UT plus half 80 square. Proof. What we did here, we simply found the area of velocity time graph, and the area of this shaded part is divided into two parts, that is one triangle and another is a rectangle, and we simply found out the area of triangle, area of rectangle, and we got this one by the application of first equation also. Okay, this relation is also called position time relation. We should remember this. Okay, this second equation of motion is also called position time relation. This is also called position time relation because S is what? S is position, T is time. So mainly it is position time relation. Okay, now let us see this. The next derivation type, that is derivation by using calculus. By calculus we can see derivation by calculus. And this is even more simple. We know V equals to what? Dx by dt. We know this according to definition of velocity. V equals to dx by dt, and this can be expanded and this can be further written as dx equals to what? Cross multiplying, we will get v dt. Why? This is done to integrate both sides. Okay, so integrating both sides, what we will get? Integral dx equals to integral v dt. Okay, and we know we need to put limits. The limits will be, this is x naught and this is x, and here it is limit of time will be put because changing of time is done. So this is 0 and this is t, so it is initially it is x naught. Okay, let us solve it. Now we can put here this v equals to what? U plus at by first equation, putting this v as u plus at, we can write here dt. Okay, this v is written as u plus at because we know it by first equation of motion. Okay, and then it is simple, solving it we will get u. This is simple calculus. Okay, a will be taken out. Why? Because acceleration is a constant. This is the first consideration of this equation, that it must be constant. Acceleration must be constant. Further solving it will come to x minus x naught. This will come to x minus x naught equals to, this will ut plus half at square it will come. Okay, ut plus half at square. Then we will get x equals to x naught plus ut plus half at square. Okay, what this x naught can be omitted because it is position at position, initial position. What is the initial position? This is the initial position. It can be at origin means what? 0. So 0 can be omitted. Okay. When the motion starts from the origin, this can be 0. Okay. This will be 0. So it is not considered. Okay. This is proved by calculus. This is proved by graphical method. Okay. Now let's see one example. Let's see the question. A car starts from rest, travels with acceleration 10. Okay, for 20 seconds, find the distance traveled. If we have to find this, what we will do? At first, the correct way to solve a question is, at first we should write what is given. Let's see the correct way. What is given? Starts from rest. It means it is given that u equals to 0. Travels and acceleration a equals to 10. This is given. Time is given, t equals to 20 seconds. Okay, these things are given. Then what we have to find the distance traveled. Then given, after given, what we should write, and to find distance means s equals to what? To find s equals to what? This is a way. Okay, now third step is write now with formula. S equals to ut plus half at square. Under bracket we should write second equation of motion. This is the correct way to solve a question for correct step marking or complete marking, you can say. U, now putting the values, u is 0 into 20 plus half into acceleration is what? Acceleration is 10. Time is 20 square. Under bracket again we will write the values given. What we are doing here, we should show here. This is the way to solve to get 100% marks in the examination. Now this will be 0 term plus half into, this is 5, so we will say 5 into 20 square means 2 2 is 4, 0, then it is 5 4 is 20, that is this much meter, 2000 meter, or you can say 2 kilometer. Now the answer step we can say, hence the distance traveled is 2 kilometers, full stop. Okay, what we are doing, we put here. And then the final step, this one is very important, it considers half marks, hence the distance traveled is 2 kilometers. Answer perfect. Thank you.